Hello everyone. Welcome to the last part of the Numpy recitation series. In this recitation, I want to talk about some common broadcasting pitfalls encountered when working with Numpy arrays. Broadcasting is a powerful feature in Numpy that allows different shaped arrays to work together in operations. However, it can also lead to some unintended results if you aren't careful. Let us consider a scenario where you have two 1D arrays of shape 4 and a 2D column vector of shape 4, 1. Now, if you element-wise multiply the two 1D arrays, you will get a resultant 1D array with the same shape as the input arrays. Had you multiplied two column vectors, you would again have ended up with a resultant column vector with the same shape as the input arrays. Now, what happens if you element-wise multiply this column vector with one of the 1D arrays? So here you will end up with, instead of ending up with a vector, you end up with a 2D matrix of shape 4, 4. So what happens here is that Numpy first reshapes this 1D array into a row vector. So the shape of this array becomes now 1, 4. And when you element-wise multiply with this column vector with shape 4, 1, you know that the row vector will now try to match and broadcast with the 4, 1 column vector before multiplying element-wise, and it will result in a 4, 4 matrix. To avoid this, you need to make sure to pay close attention to the shape of your inputs. That is, if you want a vector result, you should either use two column vectors or two row vectors or two 1D arrays. Mixing a 1D array with a column vector will result in a matrix instead of a vector. Now, let us see a case where we are going to perform matrix multiplication of two 1D arrays. So here, we are going to matrix multiply array 1 with array 2. So in this case, what Numpy does is that it will treat array 1 as a row vector and matrix multiply it with array 2, which is a column vector, and then you will end up with a scalar. In case of element-wise addition, we observe similar broadcasting behavior as discussed above. We can go through all of these examples and check them out. Another pitfall that is most commonly encountered is accidental activation of broadcasting when you meant to do something else. For example, if you swap the @ operator with the element-wise operator. For this, let us consider a scenario where we have randomly generated a 4 × 4 2D array. Now, if you matrix multiply this 2D array with one of the 1D arrays that we had defined above, you will end up with, so that 1D array will have the shape 1, 4, and if you matrix multiply it with 4, 4, you're going to end up with a 1D array. Now, however, if you element-wise multiply it by mistake, the code is still going to run. If you would have changed this operator with this operator, this code is still going to run, but you see the difference in the shapes? You're going to end up with a 2D resultant array. So always be careful of accidental broadcasting with operations like element-wise multiplication or addition when you meant to do a dot product or matrix multiplication. Always check your operator and input shapes. We see similar broadcasting behavior when we use PyTorch as well. Feel free to go through these examples given in the code and experiment it firsthand. The basics of broadcasting are very straightforward, but these edge cases illustrate how it can mislead you if you do not validate array shapes and operators. Hope you found this recitation useful. Thank you.